All right, guys. Welcome to this week's lesson slash lecture. We're going to be doing this remote this week, so this should be pretty interesting and exciting. So let's get started. So this week, what we'd like to do is work through a project, a new project that is going to explore a new library, a new tool set within P5.js. So we're going to take a look at the sound library, the P5.js sound library. So we can go ahead and look at p5js.org, and we just search for sound. There are a bunch of tools in this P5.js sound library. So we've got all these different tools. Now, most of these are objects, right? So they're objects that bring with it different functions or methods and properties, right? Internal variables to these objects that allow us to manipulate these objects to do certain things. In this case, it's all pertaining to making sounds. So with this tool set, we can actually synthesize, not even just play a sound file, but actually synthesize different sounds using frequencies and envelopes and things like that. So we're going to go through how to actually use this library today. I'm also going to link you to a couple of external resources that you can use to dive into some of the details of this library. I'm not going to go into the large amount of details in this lecture, but I will link you with other resources that you can go a little bit deeper into those. So, like we did with the other lessons, let's go ahead and sketch out what our goals are for this lesson and for this project. So I'm going to jump into Figma here and go into let's go into what we were doing in class. So I'm going to pull up this. And I'm going to create a new frame here. I'm just going to go ahead and create a new desktop frame. And let's just dive into this here. So we'll go ahead and, so basically the goal here is to design a small soundboard. So actually, before I start sketching, what is a soundboard? Let's take a look at just Google soundboard and look at some images. So we've got a couple of different types of soundboards that come up. That's interesting. A little Ada fruit chip right here. These are actually kind of cool. But I'm thinking along the lines of more of a drum style machine, something like this, right? So maybe a drum machine is a better depiction of what I'm envisioning here. Okay, kinda. Let's see. Yeah, something more like this. Specifically, this section right here that is oh, you know what? Let me just make sure I'm sharing my computer sound as well. Yes, I am. Good. Okay. Something like this, where it's just kind of a table of little buttons, right? Where each one of these buttons can be considered like a pad, right? These are different pads that you can use to kind of make sounds. So yes, think something like this. Look at this bad boy. So, not all these buttons on the left-hand side, but more like this 4x4 grid. What I'm thinking is we can make something like this on the computer and map each one of these pads to keyboard input. And then each pad in and of itself will have a specific frequency that it plays a sound at. And maybe we can play around with some of the frequencies and see what we can come up with. So if we were to sketch this out, it should be pretty simple, right? We're going to have basically just a grid of rectangles. So I'm going to go ahead and grab this, and we have a single pad, right? So this would be a pad. If we match maybe the color of that pad, we'll make it a little orange looking, right? We'll make it a little cool looking there, right? And now we'll have, a bunch of these pads here. We'll say a 4x4 grid. I'll do a 3x4 grid. Looks like it fits good there. So this is the basic idea of a soundboard, right? Super simple, just a grid of squares. But each one of these squares doesn't just represent a square, right? We know how to draw squares, right? We're drawing full scenes, right, in last class. But this square is going to be packed with a bunch of functionality within it, right? So we're going to have functionality that detects a keyboard hit and functionality really specific to the square itself, which is to play a certain sound when that keyboard hit is detected, right? So I think this is enough of a sketch to get us started on a basic soundboard, right? We'll call this. So we have this basic idea of a soundboard. So before we actually get into some of the sounds, why don't we start to think about how we would draw just a single pad, right? So with any problem that you try to solve, you want to try to break it down into its smallest component first so that we can, break it down, make it easier to solve problems, right? A lot of mathematics works that way, where you want to try to chop the problem down into smaller problems. And then you can kind of bring all the little problems together to solve the big problem. So let's start by setting up a new sketch. So let's go ahead and jump into our Stack Starter environment. And I'm going to jump into our editor here and click Edit. Now, the first thing we're going to do, I'm just going to make the screen a little bigger here so you can see it. The first thing that I'm going to do is let's go ahead and create a new file. I'm going to right-click the project and go to New File. Let's go ahead and call this soundboard.js. So super important that you create a new file. We call it soundboard.js. We're going to do all of our work in this file. So let's go ahead and hit create. All right, awesome. So now let's go ahead and open up that soundboard.js. And I have a feeling you guys know what we need to do here, right? So we need to actually scaffold the application. The first thing we need is what? Our setup function, right? So I'm going to go ahead and type our setup function. And within our setup function, we're going to want to go ahead and create our canvas. And we'll create our canvas to be the window width and the window height. Perfect. Now, let's go ahead and make the background, say, black. And awesome. So we should have this basic setup function now where we have just a black background. Now, knowing that we need to first describe a single pad, now we have to put our object-oriented programming hats on and start to think about the world from a pad's perspective, right? So why don't we get the pad in its most basic form is just a square. So how about we start to describe a pad through that lens first, which is just a square. So we're going to call these little squares pads, right? So that's the first thing, is we're establishing some vocabulary that we're going to use. When we talked about last week's lesson, we had some more kind of concrete examples of what we were talking about, right? The ground. There's only so many ways you can describe a ground, a tree, and a cloud, right? But with this, we could kind of call these different things if we chose to, right? We could call this a button. We can call this a rectangle. We can call this a sound if we wanted to. In this case, I think, and some of you might actually know this better, but I think for these types of devices, you do call these pads that you kind of tap, right? So let's go ahead and call it a pad here. So let's go back to our code, and we're not going to do the draw function just yet. Let's go ahead and start to describe a pad. And we need to start to define this blueprint, right? So when we talk about defining a blueprint, we're talking about a class. So we're going to type class, and then we're going to call it pad. We're going to open up our curly and close our curly. Now, we're going to need the first function that you're going to want to define within this class, right? The first method that we want to define within this class is what is the name of that function again? Do you guys remember what that is? It's something that actually sets up the blueprint when it gets created. It's a lot like the setup function, but within the context of a class. So in this case, we're going to call this is called the constructor. And in JavaScript, we actually call the function constructor. So you're going to say constructor, and we can pass to it parameters, which we will do shortly. and then we can open and close. Now, within the constructor itself, this is where we can set up different member properties of the actual class itself. Things like maybe its position, right? Set up the actual pad. So we could do things like set up its position. We could say maybe its X and Y position in space. But you know what would be nice if, just like we did with the tree in our previous example, we can pass to the constructor within these curly brackets and within these parentheses, I should say, an X comma Y. And now using this incoming data from somewhere else, we're going to do it in the setup function, we can then make an internal property and say this dot X equals X and this dot Y equals Y. Awesome. So now we have some really basic setup for this pad that we can now place within our canvas. But we now need to describe how to draw this pad, right? So how do we actually draw the pad? So let's go ahead and define a draw method that will allow us to draw. So I'm going to go ahead and define draw. And within this draw method, let's go ahead and draw that square. And we're going to draw that square at the specific X and Y coordinate that we passed into the constructor. So if we could do this by using the rect function. I'm going to say rect and say this dot X comma this dot Y. And then we're going to give it a width and a height, right? So in this case, let's make it a fixed width and fixed height. We will come back to this and we're gonna modify this a little bit, but let's make it a, say, 50 by 50. All right, so we have a 50 by 50 square that we're going to draw. And let's in the draw function, let's make a fill for, we'll say orange. I think that's a color we can use like this. If not, we'll go back and use the hex values. Okay, so at this point, I think we're ready to try to draw a pad to the screen. What do you guys think? Let's go ahead and give it a shot. So within our setup function, let's go ahead and instantiate a pad. I'm going to say let pad1 equal new pad, right? Now, what am I missing there? What did I do wrong? Anybody see what I just did wrong? I used the new keyword, which is right? I used the new keyword to construct an object from my class. So this class is a blueprint, and now using this blueprint, I constructed a pad. But when we construct a pad, is there any information that I need to give the pad in order to build it? There is, right? We need to pass to it an X and Y coordinate. So let's go ahead and do that. I'm gonna give it a coordinate of 10, 10. So we're expecting this pad to live at X coordinate 10 and Y coordinate 10. Okay, awesome. So is it going to draw anything right now? If you said no, that is correct. What are we missing? We need to now draw it, right? So this is the same pattern that we did within the environment we drew here, right? It's the same exact pattern. We now need to call the draw method on the pad. So we're going to say pad1 dot, using that dot notation to call into this object, dot draw. Okay, awesome. So now we should see the actual pad on the screen. We should see an orange square. But we are still missing a major piece, right? We need to link this script into our index.html. So let's go ahead and open our index.html. And let's go ahead and where we have the clouds, we're going to go ahead and put soundboard.js. And now, while we're in here, this is a super important aspect of this. While we're in here, we do need to bring in the P5.js sound library that we're going to use later. So if you don't do this, you're going to get some errors in your script. So this template that we have here, this HTML file, does have a reference to p5.sound.js, but it's commented out. You see how it's gray here? Let's go ahead and just delete these lines here. So the dash, the exclamation point, and the opening right there. And then these last lines here, the dash dash and the closing. Now let's save that. And now we have the P5.js sound library and we're bringing in the soundboard. We're not actually using the sound library yet, but we will soon. So we might as well do it all in one sweep. Let's go ahead and try to run this. So if we go here and click run, boom, there we go. We have a little orange soundboard. Well, I shouldn't say soundboards. We have a little orange pad. It doesn't do anything yet, but it's there. Why don't we go ahead and just tweak the size of this a little bit? Let's make it a little bit bigger. So I'm going to go ahead, go back here. Instead of 50-50, I'm going to make it 150 by 150. Okay. So let's go back, refresh that. Okay, awesome. That's looking pretty good. Now, I want to split my screen, but okay, I'll keep it like this for now because I'm not sure that Zoom is gonna split my screen nicely here. So I'll flip back and forth here. It'll make the code bigger too. So now we have this orange square. Awesome. Now at this point, we can continue to build out the square, and we can actually make it so that this single pad plays a sound. So why don't we try to do that, right? We want to solve for the one pad first. And once we have one pad working, then we could go ahead and create many pads off of that single template of one pad, which is kind of nice. And this is one of the real strengths of object-oriented programming is that you're going to see through this project that we can now template out this single blueprint, right? But inject variables into the constructor that changes some of the fundamental behavior of the individual instances of the specific pad, right? Think about it like each pad should have a different frequency, right? Each pad should make a different sound, right? So we want to be able to modify that. Or each pad should have a different location in space, right? A different X and Y coordinate. We don't want to draw it on top of each other. Very similar to the trees that we did last week. Okay, so now let's go ahead and let's get into the sound library a little bit. Now, like I said, I'm not going to dive crazy deep into the P5.js sound library, but we are going to use it. So let me just get my here. So we're going to use a couple of different components of the sound library. We're going to use really 3 components. We're going to have this idea of an oscillator, right? So if you go here into the reference on the P5.js site, I'll go ahead and link this to in the video down below and in the class. So the oscillator here, and hoping you guys can hear that. I am sharing my sound through. Yes, I am. Good. So you can see here that the oscillator does create this sound, and this little script here definitely. You can run this yourself by bringing it into the environment. You can see how this works. Basically, an oscillator is going to set a frequency and set an amplitude for a sound, and then actually play that frequency, right? Given some amplitude. So, and we can do things like ramp up to the amplitude and stuff. So it's kind of cool, like nice little tool in the P5.js library. And the oscillator is basically, more technically, it implements these different types of waveforms. So like a sinusoidal wave, a triangle wave, and a square or sawtooth waveforms. Now the other piece is the envelope. So this P5.js envelope, right? And the way it describes it here in the actual documentation, they're predefined amplitude distributions, right? So it's definitely not an expert in sound synthesis, right? But it defines these 4 attributes: the attack, decay, sustain, and release. And I think the way that you think about this is like like when you hit a drum, like a drum head, and you stop the sound, right? That's when you're stopping the sound in terms of how long it should sustain its sound, or when you don't stop the sound, you just kind of let it play out. Or maybe even like when you strum a chord on a guitar, if you stop the vibration of that, you're killing the sound, right? Or if you just let it go, you're letting it just kind of play out, right? So you can control those types of attributes using this object, which is kind of nice. So you could see it through in this example. Like if you click here and let go, it's going to kind of fade off. It's not going to just shut off right away. It's going to fade off using these attack and decay configurations, right? The attack is how fast it's going to ramp up to from no sound all the way up to the peak sound, and then the decay is how fast it's going to ramp down to go back to no sound. And that's why we call it an envelope, right? Where the envelope is going to like package up a sound within this kind of constrained environment. So we're going to go ahead and use an envelope in our pad just to kind of define the way a sound should play out when we hit a key. Now the third component is the analyzer, right? So where's the analyzer? Where are you, analyzer? Is it not in here? Oh, I'm sorry. We're going to call it the analyzer. It's called amplitude. Amplitude. There it is. It's called amplitude. So we're going to go here. Oh. Yeah. So in this example, we're using this amplitude here to be able to set specific sound levels. So we can actually grab the specific level of sound and use that as a variable. So you can see here, like when I hit tap play here, the amplitude object here is allowing us to get this level. And the level is going to allow us to set a size for the ellipse that we're drawing here. And what this enables us to do is make a drawing on the screen that matches the sound. So we can actually analyze the sound and then draw geometry based on attributes of that sound, right? So that's kind of cool. So if we click this, you can see that as the beat is playing, the actual ellipse that gets drawn is moving to that beat, right? So check this out. Oh, why is it not I'm not seeing the ellipse there. There it is. So that's pretty cool. We're going to use that to maybe make a little bit of a visual display within each pad so that we can see that the pad is actually playing something, right? Okay, so now we have those three objects, right? We have the oscillator, we have the envelope, and we have the amplitude. We're going to use those three objects within our object to be able to synthesize sound. So how is this going to work, right? So let's go back to our pad. Now, within the constructor of our pad is where we're going to do a good amount of the work to be able to actually construct a sound for this pad. So what did we say? We're going to use the oscillator, right? The envelope and the amplitude. Right? So we're going to need these three objects to be able to actually synthesize a sound. Right? We're not just simply playing an MP3 file. We are literally creating the sound using like an analyzer, basically, right? It's going to be like a waveform. We're constructing a waveform, which is kind of crazy, right? So let's go ahead and let's first define an oscillator, right? So we're going to say this dot, we'll call it OSC just for simplicity purposes, and we'll say new P5.oscillator. Now, it doesn't take any parameters to its constructor, but we'll keep it blank. But notice we did say P5 dot, and you want to make sure that your index.html does have that P5.sound.js file in this. So you want to make sure you uncomment out this line that we did a couple of minutes ago, because this file is where the implementation of this object is, right? So we're doing the same thing here. Just like we said, new pad here, there's an object that somebody else wrote for us that we're able to now leverage, right? So one of the other benefits of using this type of programming paradigm, this object-oriented paradigm, is that we can reuse these objects like this. So now we have this oscillator. So now the oscillator has a couple of methods we can call against it to set certain things. So we could set the actual amplitude, right? So we're going to say that at the start of playing, the amplitude should be 0, right? So we're going to say this.os.amp, which is the amp method. So if we go here to P5 oscillator and go down into the reference, you can see it sets the amplitude between 0 and 1. Right? So this is going to say whether or not it should really have any volume, right? So we're going to say 0 initially. So it's going to be quiet at first. We don't want this to just start playing right away. The next thing we're going to do is say this.oscillator.set type. Now this is going to set the type of waveform that we're going to be synthesizing. In this case, let's go ahead and use a sine wave, which is kind of a smoother sound, but you can experiment with this. So if you go back to the reference and see set type, you can see here that we can set the type to sine, triangle, sawtooth, or square. And I definitely recommend you do a little bit of research on different types of waveforms here that we can use. It's pretty interesting, and just pass in different ones and see how it sounds. Just experiment with it. In this case, we're going to use a sine. Now what we could do too is let's go ahead and start the oscillator. So we could say this.osc.start. Now we're going to also have to call this down when we actually play the sound in another method, but we're going to go ahead and call it here too. And let's go ahead and just pull up that reference as well. So we're going to go ahead and say starts the oscillator. Starting the oscillator on a user gesture will enable audio in browsers that have a strict autoplay policy. So this could be a problem with some browsers. Hopefully, this will not be a problem for us today where the browser actually blocks us, but let's see. Okay, so that concludes the oscillator. Now the next piece is going to be the envelope. The envelope is going to allow us to define how the sound ramps up and how it ramps down when it gets played. So we're going to say this.env, which is a variable that we're making up. We're going to call it env, and we're going to do the same thing we did above, except we're going to say .env, so new p5.env. And there are really only two things that we need to set within this. There's this one method called set ADSR, which sets the attack time, decay time, sustain ratio, and release time. So let's go ahead and put this in here. Now, the values that I'm going to put in here, I just kind of experimented with myself, and they seem to work pretty well. But you could just play around with these numbers to see if it fits a different sound type that you're trying to go for. So I put 0.001 for the attack time. So it has a really small attack time that the sound ramps up quickly. And I put in 0.1 for the decay time, 0.2 for the sustain ratio, and 0.1 for the release time. Again, these are numbers that I just experimented with that just seem to sound okay. You could definitely experiment with other ones. Now, the other piece is we're going to set a range. We're going to call an envelope.setRange, and this is going to constrain the envelope's range between two values, right? So we're going to say this.env.setRange, and we're going to go 3, 0. Now, again, I'm kind of just calling these methods. I'm not going crazy deep into any given one, but definitely recommend that you check out the documentation here, and the documentation for everything that I'm calling here has explanations for every single one of these. So you can see like set ADSR talks about exactly what the parameters are. These 3 are actually they're optional. You don't need to pass them in. So there's a lot more information within the reference here. You can see that we also have the set range as well. So set range is just going to set the max attack level and the min release level. So it goes max and min. That's why we have the 3, which is the higher number, first. Now, the last thing is we want to set up our amplitude, which we're going to call our analyzer. Now, what this object is going to do for us is allow us to analyze the sound. So basically, all we need to do is create a new P5 amplitude object and then set as this object an input. What sound should it be looking at? In this case, we're going to go ahead and use the envelope as the sound we're going to analyze. So I'm going to say this dot analyzer equals new P5.amplitude. Amplitude, let me make sure I'm spelling that right. Amplitude. Yeah, okay. Then I'm going to say this dot analyzer equals, I'm sorry, not equals, dot set input. And now we're going to pass to this set input method the actual, the envelope that we're going to be using, this dot env. Okay, so we are cooking here, right? Throwing a lot of code at you, but really the core of this exercise is showing you that we are using objects, right? In this case, we're using 3 objects, right? Within an object that we're defining ourselves. So we're describing this idea of a pad, and a pad now has all this functionality embedded within it. It has an oscillator, it has an envelope, it has an amplitude, it has this sound analyzer, right? And it also has positional values. So we have the ability to have an X and Y coordinate. So super cool. So we have this pad and we have this functionality. Now we have the ability to draw, but we don't have the ability to actually play any sounds yet. So why don't we go ahead and see what it's going to take to actually play a sound, right? So let's go ahead and make a new method in our code here. And we're going to call this method, I'm going to put some space in here so I can move the code up so you can see it. We're going to call this method play, right? So I'm going to say play, open and close curly. Now, the only thing we need to do here is really 3 things. We need to start our oscillator. So we're going to say this.osc.start. Then we need to set a frequency for our oscillator. So I'm going to fix this right now as a single variable, as a single value, but then we're going to use it as a variable later on, right? So you're going to see how this is going to work in both ways. So I'm going to say this.osc.frequency, and we'll make it, we'll give it a frequency of 252, right? Just making that up to some degree. What I did was I Googled notes frequencies, and there's a bunch of different resources out here for what notes in certain octaves are certain frequencies. So actually, let's make it a C note in the 3rd octave. So we'll make, that's the frequency of 130. So let's go ahead and make it 130. Okay, and now we're gonna make the oscillator play, but we need to play it within the context of an envelope, because the envelope is what controls the ramp up and the ramp down of the sound. And then the envelope is also what's being fed to the analyzer, which we're actually not using yet. But let's go ahead and say this.env.play, right? So this is going to actually play the sound. And then we're going to pass to the play method the oscillator. So this.oscillator. Okay, so now we have the ability to play something. Awesome. All right, all right. So let's see if we run this now. Let's see if this, it's not doing anything. Why isn't it doing anything? Let's look at the console. We have no errors. Okay. Well, is it going to play something? It's not, right? Because we're not actually calling the play method yet. We have to call it. So why don't we do this? Instead of calling it in setup, why don't we use one of those event functions to call it when something happens? Let's go ahead and simply use the mouse click initially. So I'm going to go right below our setup function. I'm going to say function mouse clicked. And now this code is going to execute when the mouse is clicked, right? And the mouse. And what we're going to want to do here is, since we have a pad already created, we're going to say pad1.play. Now there's a problem here. Does anybody see what the problem is? This is not going to work. Anybody know why? And if we go here and that's not playing. Why is it not playing? Let's go ahead and inspect this. Oh, look at that. We are kicking out some errors to the console. Reference error, pad 1 is not defined. Why is pad 1 not defined? We've defined pad 1 inside of our setup function, which means it's a local variable to setup. It's not a global variable for the entire script. So we can't access it here. So what do we have to do to make it so that we can access pad 1 in the mouse clicked function? If you guessed it, you have to move this over here. So we're going to say let pad 1 up here, and then we're going to take the let out here, and we're going to say pad 1 equals new pad. Now pad 1 is defined globally, and we're just instantiating it here in the setup, but then we're using it in the mouse clicked. Let's go ahead and go back here, refresh, and then boom. When we click, it's funny, I think my dog actually hears that. It's in my headphones. My dog started barking the second I hit this. So I'm hoping that my sound is playing through this recording right now. It seems like it is, but we are getting sound when we click, which is awesome, right? We're not getting any visual cue that this actually is drawing anything. So why don't we try to get some type of visual cue here? And we're going to go ahead and extend our pad to be able to do this, right? So let's go back to our code and let's go ahead and go down to our draw. Now, this is where we're going to use this analyzer. And this analyzer allows us to get some type of level, of some number to the actual value of the sound that's coming out of the speakers, right? So within this draw function, I'm going to define a couple of local variables. I'm going to say let level equal this dot analyzer dot get level, right? So this get level is going to return a value to this level variable that allows us to get either a value. I think we looked at that before. It was a value between 0 and 1, I believe, right? Let's see, that was the amplitude, right? Amplitude, and this is get level. Yeah, so it returns a number between 0 and 1. So what we want to do is we actually want to change the scale of this number to be some type of something other than 0 and 1. So we can use this function called map to be able to do that. Map, what it's going to do is allow us to take a number within a given range and then map it to another range, right? Which is kind of cool. So we can go here and we can say, let's define another variable. And we'll say level height, right? And we're going to say equals map. And map is going to take the first parameter as the level, and then the range that we're expecting. In this case, because I believe because of the actual envelope, we're going to go to 0.4. And then we're going to map it to a new range from 0 to the height of the actual rectangle. In this case, I'm going to make it 150, right? So now the level height that comes back from the analyzer is going to be mapped from between values of 0 and 1 to values between 0 and 150. It's basically just a scaling operation to the numbers. This way that we can map whatever we're going to draw to the actual size of the rectangle that we're drawing. Right? So let's see if we could do this. So we're going to draw a fixed orange rectangle, but why don't we draw maybe on top of the rectangle another rectangle that is only drawn to some maximum height when we're actually playing a sound. So let's see if this works. I'm going to say fill. Let's make it yellow so we can really see it. Fill yellow. And then we're going to draw another rectangle at the same coordinate, this dot x, this dot y, and we'll make it the same width. So we'll make it 150, but the height is going to be the value of level height. And I believe we want to make this actually negative because we want to make it go up or in the negative direction as it goes. So we don't want it to go down, right? It will draw down the y-axis. We actually want to make it draw up the y-axis. So we're going to say negative level height. Now let's see what happens. So now if we go here, refresh this. Oh, it doesn't really, I'm not seeing anything change here. This not y 150, negative level height, analyzer, get level. That was good. I'm just going to go ahead just to debug this a little bit. I'm going to go ahead and comment out these two, and we just want to draw this. So now the screen should be blank. We hear the sound. We are getting this error though. Audio context was not allowed to start. It must be resumed or created after a user gesture on the page. So I'm hoping you guys can hear this sound. If not, this lesson is going to be a little weird. But I did test this beforehand. It seemed like it worked, but we'll run with it. So we're not getting anything drawn here. So that is interesting. So let's go ahead and do this. Let's debug this a little bit. So we're going to say console.log level height. I want to see if we're getting any values here. So let's go back here. Let's refresh this. We're not getting any written out here, right? Not getting any value here. So there's something we're doing wrong here. Let's try to write just level here. Oh, you know why? I know why. Because we're actually only calling draw in the setup. Huh. So we cannot draw it just in the setup because it's not getting called anymore. So this is only being called once, but we are calling play anytime we click. So what we need to do is let's go ahead and take this out. And let's go ahead and add this back in. And what we want to do is on every frame, we want to call pad1.draw. So we need a draw function. Let's go ahead right below the setup, and we're going to say function draw. Right? And now within the draw function, we're just going to simply call pad1.draw. And we could take the draw out of the setup function. We could set the pads up in the setup, but we don't necessarily want to execute anything within them. So now if we go here, we should see the same output, but we have a little yellow going on. It's not doing exactly what we want. It's kind of like towards the top. Let's go ahead, and maybe I was wrong about the negative. Let's try this. We're just going to take the negative out of that. Now look at that. It's boring, but it's way going in the positive. So look at that. It's going way down on the screen. Let's see how far is it actually going down. Whoa. So it's going really high. So let's see, that level height is not mapping correctly. So that level height is getting a little funky, right? So let's see. Let's see what's going on here. Okay. Let's go ahead and console.log level height. All right, so a little debugging never hurt anybody, right? We go here. We can now take a look at the console, and let's go ahead and, oh, okay, look at that. So the actual value here went from 909 all the way back down. So we got really high in this level. We don't want to get that high, right? That's a little too high. So let's go ahead and pull up the map reference here because we probably are using this map function wrong. So let's go here and let's take a look at the reference. So the P5.js map function remaps a number from one range to another. In the first example above, the number 25 is converted from a value in the range of 0 to 100 to a value in the range from the left edge of the window to the right edge. So let's look at this code. So we have this value of 100, which is in a range from 0 to 100. And then we're going to map it to a range from 0 to the width of the page. So, okay. So let's go back to our code here. And we're saying that the level is within a range from 0 to 0.4, which I'm not sure it is because I'm pretty sure this said it returns a value between 0 and 1, right? So let's try to change this to say 0 and 1. And let's see if it changes the, look at that trained it a bit, but it's still going way higher than we'd like. So let's go ahead and look here. We're still going to 324. So why don't we go ahead and take a look at the actual level here. So I'm going to, instead of saying level height, let's look at level and let's really look at what the values of level are that are being returned. Because I think we're making some false assumptions to what. So look at that. It is going higher than 2. It's not between 0 and 1. It's between 0 and really kind of 2 point. Highest number we're getting there is about 2.2, 2.3. Let's go ahead and try to make this. This is like almost like a little scientific experiment, right? We're just testing little values to see where we're at. We're going to say 2.5. Let's see how that changes. There we go. That looks a lot better, right? So now that little yellow bar is staying right inside of the square, which is exactly what we want. I'm being a little nitpicky, but I don't want that little black. So let's go ahead and I'm going to take this out. Cool. That's nice. So now we have this on a clip. Keyboard, right? So this will enable us to make our keys actual little like keyboard, like an actual piano, right? We can actually play sounds with it. One really good site that allows us to see what here it is, Keycode.info. So this cool site, I'll link to it down below, allows you to basically just hit key and whoops, and it returns to you the internal JavaScript information about the actual number. Every single key on the keyboard is mapped to a number. We're going to see how we're going to use this in a second. So instead of using the mouse clicked event, we're going to use the key pressed event. So I just changed mouse click to key press. And now there's an internal variable, just like the window width and window height, or mouse X and mouse Y that we did a while back, that allows us to keep track of what key was actually pressed. The value of that variable is here that you see here. So like I hit D here and it's 68. I hit C and it's 67, right? Have these different numbers here. So I'm going to say, let's go ahead and make it the home key. So we'll say F, right? So F is 70. If, a little conditional statement here. If code equals, we'll do 3 equals here, right? Just to make it, we'll say 3 equals 70, right? That's what it said, right? 70. Then we make the add one play. So we're going to go take this, not play. Okay, awesome. So now if we go here and refresh, if I click, it's not going to play a sound. But if I hit the F key, boom, it plays a sound. All right, we are cooking. We are cooking. It's looking good. Now, we're almost there with a single pad, right? So now we have a single pad developed. But we want to be able to control the frequency of this pad from the outside world. So how do we do that, right? What do we control from the outside world now, right? So here is the outside world. We are outside a pad, right? We control the X and Y coordinate. Wouldn't it be nice though if we can also pass in the frequency of this pad so we can control how this pad sounds? So why don't we do that, right? Right now, we're setting the frequency here. And right here, it's fixed at 130. But why don't we also pass in the constructor of the pad, a frequency. So, oops, frequency there. So instead, we're going to have X, Y, and frequency. And then we'll set an internal property of this dot frequency equals frequency. Now, when we go ahead and play, instead of playing at 130, we could say this dot frequency. Awesome. So now we can make it sound exactly the same way by just simply passing in comma 130 here. Now, if we go ahead and refresh this and hit the F key, it sounds exactly the same. But if we change this to say 230, it sounds completely different. So awesome. So now we can actually create a bunch of different pads. So now we're at the point where we now have this idea of a pad, which we've developed into a nice little package here, right? So we have this little package of a pad, and now we can use this. Let me move this up so you can see the complete code here, right? We can use this now to create many pads. And that will, once we create the many pads, then we are in good shape. Now, how do we do that? Well, why don't we use the knowledge that we've learned recently with arrays to maybe define an array of pads, and then we can map each array value to a key code and then have them all play using different keys. So let's define one list here. We'll call it, we'll say let frequencies, we'll say freaks equal, and we'll some values. I'm just going to make some up. I'm going to go 100, 200, 300, 400. So we'll have 4 pads. All right, we won't go the whole 9 of having a whole grid of pads. Maybe we'll go into that a little bit more in a next lesson, but we'll have 4 pads here. And then we'll say let keys, right? So we'll map the keys equal to, and let's get the keys. We'll make the A, F, D, and F keys. So it's going to be 65, 83, 68, and 70. All right, so 65 and 83. So we'll say 65, 83, 68, and 70. So these will be the frequencies we will play. And these will be the keys that will trigger the sound. All right. And now we also need another thing. We need an array to be able to keep track of all the pads. So instead of having this fixed pad 1, we could just say let pads equal a blank array. And what we're going to do is we're going to actually construct pads based on the number of frequencies that exist in the frequencies array. So let's see how we're going to do that. So we're going to go ahead and in the setup function, we're going to populate the pads based on the frequencies. So here we're going to go ahead and remove this pad. Say we're going to use a for loop here. We're going to say for I equals 0, I is less than the length of the frequencies, right? Just like we did in the other exercise. I'm going to say I plus plus. Then we're going to go ahead and create new pads. So what we could do is we can use a new method on the array to be able to add indexes to the array. So we can say pads.add. I think it's add. I might actually be messing this up. Let me JavaScript. I add. It might actually be push. It's push. Yes, it's push. So we want to do this. It's dot push. So dot push new pad, and we'll give it an X and Y coordinate. So in this case, we're going to do the same thing we did with the, I believe we did with some of the clouds, where we did an offset here. So we're going to say, we'll start at say 10, 10. We're going to move it over in the horizontal position, right? Plus 10 times I. Now pay attention to what I'm doing with the parentheses, because that's going to matter. There's a lot of parentheses happening here, right? And now the pad is also going to have a specific frequency. So we're going to go ahead and say comma, and the frequency is going to be, right, Q sub I. Now this is a little powerful piece of code that it seems like I'm missing something here. I'm missing a closing. There we go. This is a powerful piece of code that's going to automatically fill out another list, right? Another array based on the values of a different array. So we're looping through all the frequencies and creating new pads based on those frequencies. So like a lot of places in this video, you probably want to pause it just to take a look at the code to see where we're at and get it into your environments. But this is definitely some code to study right here. This should create all of these pads. So after this executes, right, if I say console.log pads, we should see an array of pads. Before I do that, though, we do want to take out any reference to pad 1. So we do want to take out, let's take out this key code logic here, and let's take out this pad1.draw, because we're gonna rewrite that. Now, if we go here and refresh, we're gonna see nothing, but it looks like we do have some type of error. Frequency is not defined. So what did we do wrong here? So because it's freaks, not frequency. So we got to put an S there. Now let's go ahead and refresh that. And you can see here we have an array that has 4 pads in it. And the pads each have an X and Y, a frequency, an oscillator, and an envelope. It should also have an analyzer. So there we go. So each one of these pads are now created, but we haven't used them yet, right? So let's go ahead and use them. So we're going to use this same pattern here. So I'm going to go ahead and actually copy this for loop, and we're going to paste it here in the draw function. Now, instead of doing the pads.push, we're going to do pads sub I dot draw, right? So for each pad, right, using this for loop, we're going to go ahead and draw the pad, right, at a given X and Y coordinate, which we've already defined when we created the pad. So let's see what happens. They're kind of on top of each other. So offsetting it by 10 probably isn't enough, because the pads are 150 in width. So we actually want to offset it by more than 150. So maybe 155 to give it a little padding, no pun intended, padding on the pads. So there we go. So now we have these pads kind of sitting nicely next to each other. Awesome, awesome. So now it's not doing anything yet. It's not playing any sounds, but now we're going to do the same exact thing in the key pressed, right? So we're going to test for any of the keys in the key pressed and then actually play its given pad. Now this is interesting because we need to do something that we need to find the index in the key list and then use that index to play the pad within the other list. So what am I talking about, right? So this is actually something that comes up a lot in computer science, where it's actually searching an array, and there are a ton of algorithms to search arrays, right? Very frequently, an interview question for new developers, like what is the efficiency of certain search algorithms? In this case, we're going to do a pretty brute force search anytime we get a key. So we're going to loop through the keys array and find the index of the key that we're looking for, right? So what we're going to do is we're going to say let key index equal 0. So we'll have some 0 index. And then we're going to loop through all the keys. We're going to say for let I equal 0, I is less than the keys dot length, right? So every time we hit a key, we're going to loop through the keys array, and we're going to search for a key index. So we're going to say if the key code, right, equal the keys sub I, right? So if we find the key code that was pressed in the array, then we're going to say key index is equal to I. So we just found that index, right? So, and you know what? Because 0 is a valid index, we probably don't want to use 0 as the initial value of the index here. We probably want to make it something that is a little bit more of an indicator that it's not valid. So I'm going to say equals -1, right? So now what we can do is we can play if we have found an index, right? So maybe we'll do this. Well, instead of playing anything, we're going to say console.log within here, found a key. And if we go here and run this and inspect it, go to our console and hit, oops, what am I doing? And we hit one of the keys that we have, you're going to see found a key. If we hit a key that we did not, like I'm hitting the Y key right now, it's not going to hit anything. But if I hit the D key, it's gonna fire it. We're gonna find an index. So actually, you know what? We don't even need to even do any of this. Now that I think about it, we can actually take this out. We don't even need this variable. We don't need this either. We could just say, if we found it here, then we're going to say pads sub I, right? So we found an index dot play. Boom. So this is actually called something specific. It's called a sequential search. And it's pretty much the simplest type of search algorithm on the planet. It's a brute force, just loop through the whole list and see if we find something. So we're combining two key concepts here, a for loop and a conditional statement to find something. So now if we refresh this and we hit a key that is not mapped, say we hit the I key, it's not going to do anything. But if we hit the F key, the F is going to go off, and the D key, or the S key, or the A key. How cool is that? Awesome. So we have a working soundboard. Very, very cool. And now this working soundboard is extensible very simply by just adding entries to this list. So if we wanted to add another button, we could say, all right, maybe we want to add, say, the G key. So we're going to add 71. So I'm going to go ahead and add comma 71 here. And I'm going to add another frequency here. I'm going to say 500. Right? So now you want to make sure that these arrays should have really the same shape, right? They should have the same length. They should always match. If they don't match, there's probably a problem. So you always want to make these match because they're always going to, one key is going to map to one frequency. So now if we go ahead and refresh this, you're going to see another box there. Automatically maps. Now, as a bonus challenge, I'm not going to do this on this video because I know this is going pretty long. But on a bonus challenge, see if you can get boxes to go into a grid. So once they get maybe to 4, maybe go down to a new line. A hint with that is that our y value here is fixed. We want this y value to increment based on the values of the loop. So go ahead, guys, try to follow along with me with this. The assignment for this week is to get this to run and then submit it to the assignment. I'm not going to post the code to this fully just yet. I'm gonna wait probably until midweek to post it because I don't want you guys just copying and pasting it. I want you to kind of play along with it. So play along with me with this. See if you can get this to run. I think it's a super cool project. You can kind of play around with it, play with different frequencies, different keys. And you know what? We don't need this pad one up here too, right? We're not using that anymore. So let's get that out of here. But yeah, that is pretty much it. So we have this nice little soundboard. Maybe even combine frequencies that make woods, right? We can do that. Play with the attack values and stuff like that. All those values should affect the actual analyzer and how it visualizes itself when you play stuff. So have fun with it. And if you have any questions, you know where to find me. Reach out. You'll have all week to do this, right? So we're not meeting in class this week. And yeah, have fun. Thanks, guys.